All right, guys. So our next lesson is going to be kites and trapezoids. So this is still quadrilaterals, okay, but these are just two different types of four-sided figures. So a kite is a quadrilateral with exactly two pairs of consecutive sides that are congruent. If a quadrilateral is a kite, which is FGHJ, then it has the following properties. Okay, so the difference between the kites is instead of the opposite sides being the same, these two are the same, then touch each other, which means consecutive, they're right by each other, and these two sides are the same. Okay, usually one set of sides is a lot longer than the other side. So for our properties of kites, the first one is that the diagonals are perpendicular. So just like your rhombus, your diagonals here are also going to be perpendicular as well. Okay, they make a right angle when they cross. Okay, the next thing is there's exactly one pair of opposite congruent angles. So these two that are opposite each other are congruent. So then here it says find the measure of the indicated angles. So based off of that information that we just did, if this is 88, then this one is 88 also. So the measure of angle K is 88. And then to find angle J, we know that the four angles of a quadrilateral should add up to 360. So we're going to have to subtract the 88, the other 88, and the 120. And that'll give us the third angle J. So let me put that in my calculator real quick. It gives me 64 degrees. All right, the next one. So here it says find the measure of the indicated angle. So they tell us that J is 60 and L is 50. Now M and K should be the same. So first I'm going to go ahead and take the 360 and subtract the 60 and subtract the 50. And that is going to give me 250. And because M and K are the same, all we got to do is divide that by 2. And that means each one is 125 degrees. Okay, so here it says in kite ABCD, the measure of angle BCD is 98 degrees. So B to C to D is this angle right here, the whole thing. That one is 98 degrees. Okay. Then it tells you and ADE is 47. So A to D to E is 47 degrees. Okay. We also know just based off of the rules that we learned earlier today, that this angle right here where they intersect is 90. So this is 90, this is 90, this is 90, this is 90. All right, so if this angle is 47 and this one's 90, if you notice we have a little triangle going on right here, then we can find the other angle that's in here by doing 180 minus the 90 minus the 47, and that actually gives me 43. So that means this angle is 43 degrees. Because these two triangles are the same, this triangle is the same as this triangle, then it's going to have the exact same measurement. So that means this one's 43, this one's 47. We did it in a different color. And then let's see. Since we know this whole thing is 98, and we know that little piece is 43, I'm going to go ahead and do 98 minus the 43, and that gives me 55. So that means this side is 55, which will make this side 55 as well. Okay. Then from there, we have this triangle here. Okay. So because that is a triangle, the three angles need to add up to 180. I already know one is 55 and the other one is 90. So I'm going to go ahead and subtract those, and that gives me this inside angle, which is 35 degrees. Okay, so if that one's 35, then that means this one is also 35. All right, so let's go ahead and answer the questions. The first one's asking us for DAE. So DAE is this one right here, which is 43 degrees. The next one is asking us for BCE, which is this one right here, which we said is 55 degrees. And then last is A, B, and C. So A, B, C is this one here, which is both of these 35s together. So together that gives you 17. The next one says find the side lengths of the kite. So because this is a kite, we need to remember that they intersect and make a 90-degree angle here. Okay. That means that we have a right triangle here. So to find the side lengths, we can use a squared plus b squared equals c squared. So 9 squared plus 8 squared equals c squared. I'm going to go ahead and put 9 squared plus 8 squared in my calculator, and that gives me 145 equals c squared. I take the square root, and it gives me 12.04. Okay, so because this one has the same measurements, 8 and 9, this side should also be 12.04. Okay, now I'm going to do the other side of the triangle, which is this side here. I have my right triangle. One of them is 9, the other one is 7. So I'm going to do 9 squared plus 7 squared equals c squared. So I'm going to go ahead and put that in my calculator. That gives me 130 equals c squared. We take the square root, and the square root of 130 gives us 11.40. So that means this is 11.40 and this is 11.40. That's it. All right, the next part, it says a trapezoid is a quadrilateral with exactly one pair of parallel sides. So these sides are parallel. Okay. Each side is called a base, and the non-parallel sides, so the ones that aren't parallel, are called the legs. So just like triangles have legs, this one also has legs as well. Base angles are two consecutive angles whose common side is a base. So these are called consecutive angles. Okay, they should be congruent. So here's the properties of not any type of trapezoid, but specifically an isosceles trapezoid, which means these two sides are the same. Okay, so if those two sides are the same, then your base angle should be the same. So B should be the same as C, and A should be the same as D. Okay. Also, not just that, but your diagonals on your isosceles trapezoid are going to be congruent, which means they are equal in measure. So let's go ahead and try out some problems. It says here, find the measure of all the angles in the trapezoid. So here, if this one is 124, angle L, so is this one right here, angle K. Okay. Now this is a quadrilateral. It still has 4 sides, so we're going to go ahead and take the 360 and subtract the 2 angles that we know. We know both of these are 124. So in my calculator, I'm going to do 360 minus 124 minus another 124 to give me 112. So that means together, these two need to add up to 112, and since they're equal in measure, we can divide it into 2 equal parts, which is 56 each one. All right, so here it says in the trapezoid EFGH, FH equals 9. So from F to H, this whole thing is equal to 9. Okay, that means from E to G should also equal 9, the whole thing, based off of the rules that they give us. From A to G, they don't tell us what it is, but they do tell us that this is 6.2. So we're going to do 9 minus 6.2. That gives us 2.8. And then last, it asks us from F to A. From F to A should be the same from E to A. So it'll also be 6.2. 6.2. All right, the next one says ABCD is an isosceles trapezoid. Find the value of Z if from A to C is 2Z minus 9. So from A to C, this whole thing is 2Z, plus 9, sorry. And from B to D, so this whole thing from B to D is 4Z minus 3. Okay, so because of the diagonals, they should be equal in measure. So I'm going to set it up 2Z plus 9 equals 4Z minus 3, and we're going to solve for Z. So first I'm going to move over this Z to 2Z. This cancels, we get 9 equals 2Z minus 3. I'm going to move over this plus 3, and we get 2Z equals 9 plus 3 is 12. Sorry, I kind of flip-flopped them, but it still means the same thing. We divide both sides by 2, and we get Z equals 12 divided by 2 is 6. All they're asking us is to find the value of Z, so that's it, we're done. Okay, the last section, it says a mid-segment of the trapezoid. So the mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the legs. So pretty much they get this side and they cut it in half, and that's A. They take this side, they cut it in half, and then this is B. Okay, it doesn't have to be an isosceles trapezoid, it can be any kind. So the mid-segment, there's a formula. The formula is you take the bases and you add them and divide it by 2, and that'll give you this mid-segment from A to B. Okay. So for example, here they're asking us for the mid-segment KL. So all we gotta do is we have to add the two bases. So we add the 16 plus the 26, and we divide that by 2, and that'll give us the distance from K to L. So 16 plus 26 divided by 2 gives us 21. Okay. This one, it's working us a little bit backwards because they don't give us both of the bases, okay? So they give us 5.5 as one of the bases, and the other one we don't know. Let's call it x. That's what they want us to find from P to Q. So when we take that and we divide it by 2, it should give us 7.5. So we're going to work backwards to solve for x. So we multiply both sides by 2. We get 5.5 plus x equals, the 2's canceled here, 7.5 times 2 gives us 15. Then we move over the 5.5 to the other side, and that gives us 9.5. So x equals 9.5. That means that from P to Q is equal to 9.5. Okay, and then the last problem, it says find the value of x. Okay, so here we're going to go ahead and add the bases. So our bases are in terms of x. So one of them is 2x, the other one is 8x plus 2. We divide it by 2, and that gives us our mid-segment. Here our mid-segment is 17.1. Okay, and we're solving for x, so first we're going to get rid of this 2 by multiplying both sides by 2. We get 2x plus 8x plus 3.2 equals, the 2's have to cancel each other out, and I'm using my calculator. I'm going to do 17.1 times 2 gives me 34.2. Okay. We combine our like terms, so 2 plus 8 gives us 10x plus 3.2 equals 34.2. We move over the 3.2 by subtracting it, and that gives us 10x equals 31. We divide by 10, and we get x equals 3.1. And that's it. If you guys have any questions, go ahead and let me know. That's it for me today. Thank you guys. Bye.